Here's an equilibrium problem. We'll start by writing the balanced chemical equation. CO gas plus H2O gas, CO2 gas plus H2 gas. K sub C is going to be CO2, H2, our reactant CO, and H2O. Okay. So we're asked to find our equilibrium concentrations. We're going to use an ice table. Alright, so we start with just CO and water, and we're given amounts in moles and said that it's placed into a flask. So we're going to have to calculate what our initial concentrations are. Remember, ice tables contain only concentrations for K sub C, or if you're dealing with K sub P, they have partial pressures. So we have the same number of moles of each CO and H2O, and that is 0.250 moles in 125 milliliters. We convert that to liters so we can get our concentration in molarity. Okay, so these are the initial concentrations of CO and H2O, our reactants. We don't have any products to start. Alright, so if we move towards equilibrium, we have to be going left to right. So we're going to lose X of each of the reactants and gain X of our products. Alright, so K sub C, which is 1.56, it's given to us in the problem, is going to be equal to X times X divided by 2 minus X and 2 minus X. Alright, we have one equation with one unknown, and we're trying to solve for X. We could expand this out by a FOIL and solve this that way. However, very quickly we can solve this if we notice that this is a perfect square. Meaning if we take the square root of this side, we get, in this case, X over 2 minus X. So we have the square root of 1.56 is going to be equal to the square root of X over 2 minus X times X over 2 minus X. Okay, we need the square root of that side. So if we take the square root of 1.56, we get 1.249, and on this side the square root is obviously going to be X over 2 minus X. Alright, so clean this up a little bit if we could. I guess we can't. Alright, so what we're going to do now to solve for X is to do a little cross multiplication. So we have 1.249 times 2 minus X is going to be equal to X. If we expand this, we have 1.249 times 2, 1.249 times minus X. So we have 2.498 minus 1.249 times X is equal to X. We collect the like terms, which in this case means we can add the 1.249 times X to each side. We have 2.498 is equal to 2.249 times X, and X accordingly is equal to 1.1107. Alright, so now that we have X, we go back to the original ice table to find out how we can solve for our problem. We're trying to find the equilibrium concentration of all these species, so we can just plug X in and we're done. So the equilibrium concentration of CO and H2O are equal, and they are both equal to 2 minus X. So this is 2 minus 1.11 and that equals 0.89. And CO2 and H2 gas have the same equilibrium concentration, and that is actually equal to X. So that is 1.11 molar.